Hello and welcome to my tutorial on encryption with Python. Someone made a request for this video, so I went ahead and made it. It's going to be a little bit longer than most of the videos. By a little bit, I mean a lot of it. Simply because there's a lot of information to pass on with this. And I can't really make it in chunks because it kind of needs to be all together. So if you don't like long tutorials, I'm sorry, encryption isn't going to be for you. Anyway, so to start, we're going to need some sort of encryption software because you're not going to be able to encrypt yourself. It's pretty complex stuff. So you'll want to get at least some sort of import for encrypting. So you'll want to go, this is the website for PyCrypto, which is probably the most popular encryption tool with Python. I would just download the latest version. You just click here and you'll download the tarball. If you don't have... I'm not really talking too much about this. If you don't have anything to extract the tarball with, you can use this program called 7-zip. It's like 7-zip or something like that. And that'll get the files out. And if you don't know how to actually open up the or install the file, it's usually pretty easy. Let me open up a command prompt. Hello, I'm going to go ahead and re-record this. I just noticed in the video that my command prompt is probably one of the worst colors possible for seeing what's actually being said, so we'll just change it here. So when you open up the command prompt, now again this is a command prompt, not the Python interpreter. Let's say you've got the file on your desktop, you'll use CD for change directory, and you'll choose desktop. Like it's basically change directory into something that you're already in, but you can type out like the full directory too if you want. But anyway, that's just command prompt lingo. So now that you're on desktop, I've got PyCrypto on my desktop, so I'm going to say CD into PyCrypto. I've got it's like a file folder basically for PyCrypto. What did I do wrong? Oh, we didn't have the Y there. PyCrypto. There we go. And then so once you're in the PyCrypto folder, you should see like a bunch of stuff in that folder. Like this is the folder here, you've got build, blah, 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 all this stuff. And if you scroll down, here's a setup.py. That's the file that will basically set up whatever install that you want to do. And so the way that you do that is you type in Python setup.py and then install. Now I've already installed it myself, so I'm not going to do it, but then you would just hit enter here, and that will install PyCrypto and really any other import that has setup.py in it. So once you've got it installed and downloaded from here, generally you're gonna, well, first I'll teach you how to do it, but most, if you're encrypting something, it's because you're transferring it or you're maybe storing it for yourself or something. But encryption and decryption kind of go together. And so I'm going to have to show you them both, and what I'm going to do is just kind of split them up, and I'll have an encryption file over here and then a decryption file over here. That way you can kind of understand what's going on. So to start off, once you have PyCrypto set up properly, you'll need to do this import. You'll do from crypto.cipher import AES. Now, there are various forms of encryption. AES is just kind of one of the many forms. And generally, there's two different types of, encryption processes. There's symmetric key algorithms, and this is where you have the same key for encryption and decryption, which is what AES has. And then there's also asymmetric key algorithms, where you have one key for encrypting and then one key for decrypting. Generally, the more accepted version of encryption is indeed AES, and you want 128-bit encryption. Just for the record, we'll talk about that in just a moment as we get to it. But yeah, AES is probably the most popular form of encryption anyways, so that's what we're going to use. The next import that you're going to need is base64, and what base64 is used for is actually encoding. And you don't want to get that confused with encryption. They're two very different things. Basically, encoding is for putting data in a specific format. so it can be recognized by, it's kind of like, you know, you convert something to a string or something, like it needs to be in a specific format to be read by something. That's what base64 is doing. It's encoding it, kind of like encoding a URL so it can be recognized. It's the same stuff. So you'll need base64 for encoding. And then the third and final import that we're going to need is import OS. And the reason for OS and what we want an OS for is for the function called urandom, which is kind of an accepted producer of randomness that's suitable for cryptology. Simple random isn't really as accepted. I mean, you could use it, but people prefer urandom over that. So moving right along, now we're going to define our encryption function. So we'll say encryption, and then within here we're going to do, we'll just say our variable, or our parameter rather, is going to be private info. And so the first thing that we want to specify is block size. And basically you can choose between 16, 24, and 32 for AES. And that's going to correspond to bits. Like these are bytes, and then it corresponds to bits. So you could do 32 bytes for 256-bit encryption, or you can do 16-bit or 16 bytes for 128 bits, and so on. So we're going to do 16-bit or 16 bytes for 128-bit encryption, which is the accepted. Just as an aside, if you're trying to learn how to do encryption because you accept maybe like people's credit card information online or something like that, you're kind of like obligated to encrypt their data. And the basic, I'm trying to think, like the widely accepted, the one that the U.S. government backs is 128-bit AES encryption. So that's what I suggest you use if you're liable for any of the information that you're storing. But also the reason they support it is because it's good. Just another side, basically, you can go as low as like a 32-bit encryption, and basically with today's computational power, a decent computer would have that key just by brute force techniques only. They could have that key cracked in probably like less than an hour. So 32-bit keys are not very protective at all. The 64-bit key is getting closer. It would take probably like a few months with a decent computer, and that's only if if you ran through all 100% of the combinations. Like if you don't have like, it's highly likely that you're not going to run through 100% of the combinations before you find the correct one. But anyway, with a 128-bit, this is considered pretty safe at the moment, just because it would just take like centuries with a bunch of computers to crack it. But obviously over time, as processors get better and better, you're going to need better encryption. So anyways, moving right along, after block size, the next thing you have to define is padding. This is the only thing that really confuses me. It's like some sort of algorithm that you can use, but you can put like anything in here. Like you can put like 9999, all this kind of stuff. Like apparently like this open curly braces is like some sort of algorithm. If you understand that, let me know. I don't really understand it myself. I just know that that's what people do, so that's what I'm doing. And I guess the reason you use padding at all is so it's for sure like whatever your the values that you encrypt are a multiple of the block size and length. So this is just like you use some sort of padding to ensure that that is the case, so it can actually be like understood and decrypted later on. So now the next thing is unify just pad, and to do this we're going to call lambda, and our parameter for lambda will just be c, or actually I'm sorry, lambda, our parameter will be s, and then we're going to say s plus block size minus the length of s, and then block size times padding. So what's happening here is we're actually like gonna this is the process to actually pad the data with our padding up here. just as a quick aside, let me show you what Lambda is, since if you're not familiar with Lambda, you might not understand how this works. So I've just brought up a command prompt here. Oops, actually, let's close that out. I just need to have Python up. So if you're not familiar with Lambda, let me just show you how Lambda really works. It's kind of like a really, really quick way to embed a function in a function, and it's like a one-liner function. It's just really easy to do it. Or really like a function and a variable. Anyway, so just as a quick example, let's say we want to define our variable as addition equals, and then lambda, and this basically, like, lambda is like notifying Python that we're about to do this really weird thing. And then kind of like a function, you have to define what your parameters are, but there's no parentheses. So you do like lambda x, and then just like at the end of a function, you have to have a colon, and then you specify how you want that function to work. So we're just going to say x plus 5. Okay. So hit enter, and now that's been defined. So now what you can do is you can say addition, and we'll do 3, so it should give us 8. And sure enough, it gave us 8. And that's all thanks to this lambda. Now the reason why it's actually used in encryption is it's used for abstraction of functions. So that's really the reason why you're using it within with encryption, basically. So moving right along now, we're going to define how we want this to be encoded, and so you're going to we'll call this encode AES equals, and then we'll hit up lambda again, C, and then S, basically to correspond here. We want to call base 64, and again, this is base 64 is for encoding dot b64, I want to say encode, and then so that's what you're actually going to encode, and then you want to encode whatever the C variable is, or C parameter rather, C dot encrypt. Then we want to encrypt the padded version of this S variable, basically, or S parameter, and close that again, and one more time. And I want to say, okay, yeah, so we're done there. Now what we need to do is basically every encryption has a key, and so now we need to generate this key. So we're going to call the key secret, and that's going to be equals OS urandom, which is why we imported OS up here. Urandom, and then you have block size here. Block size. And then, just so we can actually see it, we'll want to say, print encryption key and secret. And now what we need to do is establish a cipher object, basically. So to do that, you're going to need cipher equals AES.new, and then secret. I think we've added a space here. And then finally, we encode whatever our string is going to be. So encoded, we'll call it, equals encode AES, which is talking about here. And now our two variables, because our encode AES is lambda C comma S. So there's two parameters that were given here. So now you have to specify the two parameters that you want. So you've got cipher and then private info. Oops. And as you can see, what it's going to do now is it's going to do cipher. It's going to encrypt the cipher, and then basically it's going to take the cipher, encrypt with the padded version of S. This is the easiest way I can say that, which wasn't very easy. And then finally, you can print out encrypted string colon comma and then encoded. And now we have hopefully explained to you how encryption works, and now let's see what it looks like for us. And we'll call encryption, and then inside here is where we're going to put a secret message that is very sensitive, and we want no one to read it, even the government. Hit enter. And as you can see, here's our encryption key, and then this is the actual encrypted info. Now, just as an aside, what you can do later on is you could just say cipher equals, and then, oh, we misspelled string, that's going to bother me. Anyway, you could say secret, I'm sorry, not cipher. You could say secret equals, so instead of generating a new one, this is how you would generate a new key. But instead of doing that, like say you've already established a key that you like and you've maybe memorized for yourself, you would just put this within there, and then you're obviously, like, this is non-ASCII coding, which so you'll have to have something up there. But I'll show you that in just a second because we're going to need it for the decryption anyways. Okay, so... let's run this one more time since something went awry there. Actually, let me close it so we don't get confused. So again, encryption, private information that you do not want the government to see. Close it. Okay, and then here's our new encryption key, because again, we generated a new one. But again, you can't just generate new encryption keys every time. You need to generate just one. If you're sending the data across somewhere, you're going to need just one encryption key. And so, like, both sources are going to need to know it. So anyway, now over in decryption, how do we actually decrypt this stuff? Now that we have the key anyways. So, same imports as before. I'm just going to copy and paste them over. And now we need to define decryption. And then within the parentheses, we'll just say our parameter is encrypted string, colon, padding. We're going to say is the exact same padding. I'm pretty sure you're going to have to keep that the same. Now we define decode AES, and then we have our lambda function, lambda C, comma E, and we're going to do c.decrypt using base64.b64 decode, because we're going to have to decode the encode of this information, and then obviously the variable in there is going to be E now, .rstrip, and we're going to be stripping away the padding that we added before. So padding, now our encryption, I'm not sure why I've done this encrypted string. Let's see, I guess what I would want to do is just we'll say the key equals, and we'll define our key now, which is this. And once we run it, it's going to tell me I've got some funky coding and what to put up here. I don't really know what to put up there just yet, so we'll wait till we get to that point. Because this is clearly non-ASCII characters. So the next thing we want is cipher equals AES.new, and we're going to want to use the key that we had before for the cipher, and decoded then is going to equal decode AES, so obviously we're referencing up here, cipher using that cipher that we've just said, and then we want to use it on the encrypted string. Close, and then finally print decoded. So hopefully we've not spelled anything wrong. Yeah, sure. Okay, so we need to add this to the top of the file. Hit OK, but if you also just hit edit my file, it'll go right up there for you. So we'll use that, save it, we'll run it, we'll bring it over here, and then what we'll do is we'll take this information here and we'll say decryption. Now we've already put this key into here because the Python shell isn't going to automate, like you would have to have this coding in there beforehand. But what you could do is instead of saving the key in here, since we already know it's going to be CP1252, I'll show you guys in a second that you could take key out and then put it in this parameters here. Because obviously you're not going to want the key to be in your script, like you don't want to save the key anywhere. So anyway, I guess you could have the key in there, but generally you probably wouldn't want to if you wanted to be super safe. You would probably want to be pulling the key from another file that possibly encrypted itself. What was I doing? Oh, encrypted string. So we just need to slap this misspelled encrypted string right on in there. Hit enter, and sure enough, it decrypts it into private information that you do not want the government to see. And that's really it. That's all you have to do encryption. So anyway, I hope you guys enjoyed. Hope you maybe learned something, and until next time.